true projects. In this video, we are going to explain about the project title, Intrusion Detection for Maritime Transportation Systems with Batch Federated Aggregation. Introduction. The project centers on developing an intrusion detection system tailored for maritime transportation, aiming to detect and mitigate potential security breaches within the maritime domain. Enhancing maritime cybersecurity is critical to safeguarding valuable assets, infrastructure, and data, ultimately ensuring the safety and smooth functioning of maritime transportation systems in an increasingly digitized world. Traditional intrusion detection methods in maritime systems often lack adaptability and struggle to keep pace with evolving attack strategies, hindering timely threat detection and response in a dynamic maritime environment. Machine learning provides the ability to model complex patterns, enabling effective intrusion detection by learning from diverse maritime data. It offers an opportunity to enhance data accuracy and responsiveness, crucial for ensuring maritime cybersecurity. Objective: the project aimed to create a robust intrusion detection model specifically tailored for maritime data by combining convolutional neural network (CNN) and multi-layer perceptron (MLP). CNN are highly effective in extracting features from the spatial data, making them suitable for the patterns present in maritime data. The project utilized federated learning, specifically the Fed-batch approach, to train the intrusion detection model locally on individual vessels. This approach ensured data privacy and security by avoiding the centralization of sensitive information, a critical consideration in the maritime domain. CNN was employed for efficient data feature extraction, especially for spatial maritime data. This choice was based on the capability of CNN to capture intricate patterns present in such data. Utilizing CNN enhanced the model's ability to understand complex patterns, critical for accurate intrusion detection. The proposed model and federated learning approach were evaluated using the NSL-KDD dataset. This evaluation was crucial in demonstrating the effectiveness of the intrusion detection model in the context of maritime systems. The result from this evaluation provided insights into the model's performance and its potential for real-world application in maritime cybersecurity. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following steps. The first step is importing the packages. This step involves importing necessary libraries and packages required for data processing, visualization, machine learning, and deep learning. Common packages include Pandas, Keras, NumPy, Seaborn, and Matplotlib. Exploring the dataset. KDD Cup dataset. In this step, the KDD Cup dataset, which is likely a crucial part of the project, is explored. This includes understanding the structure, features, and characteristics of the dataset. Data processing. Data processing involves preparing the dataset for analysis. This includes handling missing values, dealing with outliers, converting data into a suitable format for further processing. Creating Pandas data frame and Keras data frame. The dataset is organized into Pandas data frames, a tabular data structure for easy manipulation and analysis. If using Keras, a Keras data frame is prepared to be used as input for the model. Dropping unwanted columns. Some columns of features in the dataset might not contribute significantly to the analysis. In this step, unnecessary or redundant columns are removed to streamline the dataset. Visualization using Seaborn and Matplotlib. This step involves using Seaborn and Matplotlib libraries to visualize various aspects of the dataset. Visualization helps in understanding data distributions, relationships, and potential patterns. Label encoding using label encoder. Categorical variables are encoded into numerical format using techniques like label encoding. This is often necessary for machine learning models that require numerical input. Feature selection. Based on domain knowledge or using feature selection techniques, the most relevant features, columns that contribute to the objective are selected for model training. Splitting the data to train and test for deep learning and training X and Y for machine learning. The data set is divided into training and testing sets. The training set is used to train the machine learning or deep learning models, while the testing set is used to evaluate model performance. X represents the features or input data and Y represents the labels or target variable that the model aims to predict. For intrusion detection, X include features like network traffic data and Y would be whether an intrusion occurred or not. Building the model. This step involves constructing the machine learning and deep learning models for intrusion detection. In this project, various models like multi-layer perceptron (MLP), convolutional neural network (CNN), gated recurrent unit (GRU), and combinations like CNN plus MLP are utilized. MLP, multi-layer perceptron. MLP is a type of feed-forward neural network where information flows in one direction from input nodes to output nodes. It's likely used as one of the models for intrusion detection in this project. CNN, convolutional neural network. CNN are widely used for image and pattern recognition. In this context, CNN is used to effectively extract features from spatial data relevant to maritime transportation systems, aiding in intrusion detection. GRU, gated recurrent unit. GRU is a type of recurrent neural network often used for sequence-related tasks. It may be employed to capture temporal dependencies and patterns in the data for intrusion detection. CNN plus MLP. Combining CNN and MLP leverages the strengths of both architectures. CNN is proficient in feature extraction, while MLP is effective in classification. This combination enhances the model's ability to capture complex features and classify intrusions accurately. Ensemble models involve integrating predictions from multiple individual models to create a more robust and accurate final prediction. In this project, ensemble models are likely used to improve the overall accuracy and reliability of the intrusion detection system. This step involves creating the user interface and interaction components for the project using Flask, a micro-web framework in Python. It provides a platform for user testing and authentication. Training the model. After building the models, this step involves feeding the training data into these models. The models learn patterns and features from the data to make accurate predictions during intrusion detection. Flask framework with SQLite for sign-up and sign-in. Utilizing Flask, a web framework in Python, combined with SQLite, a lightweight database, allows the creation of a user authentication system. Users can sign up and sign in to access the system securely. User gives input as feature values. Users input feature values relevant to intrusion detection. These features are likely related to maritime transportation data, which the model will use for predictions. The given input is pre-processed for prediction. The feature values inputted by the user need to be pre-processed to match the format expected by the trained model. This ensures consistency and accuracy during prediction. Trained model is used for prediction. The pre-processed input is passed to the previously trained models MLP, CNN, GRU, CNN plus MLP or ensemble models. The model predicts if there is an intrusion based on the provided feature values. Final outcome is displayed through front end. The final outcome, which is the prediction of intrusion or non-intrusion, is displayed to the user through the front end. The user can interpret this prediction to understand the system's response based on the provided input. Accuracy comparison graph. This is the accuracy comparison graph. On the x-axis, we have the accuracy score, and on the y-axis, we have the algorithm name. And from this graph, we can say that the ensemble models perform well. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances to the total number of instances. Precision comparison graph. This is the precision comparison graph. On the x-axis we have the precision score, and on the y-axis we have the algorithm name. And from this graph we can say that the ensemble models are performing well. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives to the total number of positive predictions. True positives plus false positives. Recall comparison graph. This is the recall comparison graph. On the x-axis we have the recall score, and on the y-axis we have the algorithm name. And from this graph we can say that the ensemble models perform well. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances. True positives plus false negatives. F-in comparison graph. On the x-axis we have the F-in score, and on the y-axis we have the algorithm name. And from this graph we can say that the ensemble models perform well. F-in score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the File Explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is this localhost, and port this. Now copy this local link provided by the Flask framework. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. This is the home page of the project displayed in the browser. This is the front end built using Flask framework. Click on sign up button to register. If we are a new user, we need to register first, but I have already registered, so click on sign in. Here we need to enter the username and the password which we have created, and then click on login. We have logged in. So here we need to enter these parameters first to predict the attack and its type. So I'm entering the parameters now. So here I have entered all these parameters. The first parameter is protocol type, which is 1. Protocol type represents the protocol type of the network connection. Example TCP, UDP, ICMP. Service is 19. Service denotes the service on the destination host to which the connection is made. Flag is -0.012. Flag indicates the status of the connection. Example normal, error, etc. SRC bytes is -0.388. SRC bytes is the number of bytes sent by the source to the destination. DST bytes is -0.096. DST bytes is the number of bytes sent by the destination to the source. Wrong fragment is -0.080. Wrong fragment indicates the number of fragmented packets that were incorrectly fragmented. Hot is -0.203. It denotes the number of hot indicators frequent access in the connection. Logged in is -0.72966. Logged in represents if the user is logged in. Num compromised is -0.353. It specifies the number of compromised conditions. Count is -0.64. Count represents the number of connections to the same host has the current connection in the past 2 seconds. SRV count is -0.642. It denotes the number of connections to the same service as the current connection in the past 2 seconds. Server rate is -0.3708. It is the percentage of connections that have SYN errors. SRV server rate is -0.322. It is the percentage of connections to the same service that have SYN errors. Error rate is -0.64. It is the percentage of connections that have REG errors. SRV error rate is -0.72. It is the percentage of connections to the same service that have REJ errors. Same SRV rate is -0.28. It represents the percentage of connections to the same service. Different SRV rate is -0.25. Denotes the percentage of connections to different services. SRV different host rate is -0.76. It is the percentage of connections to different hosts. DST host count is 0.64. It is the number of connections to the destination host. DST host SRV count is -0.28. It is the number of connections to the same destination host and service. DST host same SRV rate is -0.36. It is the percentage of connections to the same service on the destination host. DST host different SRV rate is -0.85. It is the percentage of connections to different services on the destination host. DST host same SRC port rate is -0.36. It is the percentage of connections from the same source port. DST host SRV different host rate is -0.79. It is the percentage of connections to the same service from different hosts. DST host error rate is -0.35. The percentage of connections that have SYN errors for the same service. DST host SRV error rate. It is the percentage of connections that have SYN errors for the same service to the destination host is -0.36. DST host error rate is -0.33. It is the percentage of connections that have REJ errors for the same service to the destination host. DST host SRV error rate is -0.765. It is the percentage of connections that have REJ errors for the same service to the destination host. After entering all these parameters, click on Predict. Here we got the result. Attack is detected and it's probe attack. Now we will enter another set of parameters to detect the attack and its type. So I'm entering the parameters now. So here I have entered another set of parameters. Protocol type is 1, service is 45, flag is 5, SRC bytes is -0.12, DST bytes is -0.03, wrong fragment is -0.096, hot is -0.09, logged in is -0.72, num compromised is -0.35, count is -0.64, SRV count is -0.64, error rate is -0.37, SRV's error rate is -0.322, error rate is -0.64, SRV error rate is -0.72, same SRV rate is -0.28, different SRV rate is -0.25, SRV different host rate is -0.76, DST host count is -0.64, DST host SRV count is -0.28, DST host same SRV rate is -0.36, DST host different SRV rate is -0.85, DST host same SRC port rate is -0.36, DST host SRV different host rate is -0.79, DST host error rate is -0.35, DST host SRV error rate is 2.5, DST host error rate is -0.33, DST host SRV error rate is 1.59. After entering all these parameters, click on predict. So here we got the result, attack is detected and it's DOS attack. So in this way, by entering all the parameters, we will predict the attack and its type. Now sign out. The conclusion of the project is, the project devised a model that integrates convolutional neural network CNN for efficient feature extraction and multi-layer perceptron MLP for precise attack classification. CNN excel at recognizing patterns and features, particularly useful for spatial maritime data, while MLP are efficient in classification tasks. This combined architecture enhanced the model's accuracy in detecting intrusions. The project incorporated FedBadge, a technique utilizing federated learning, while allowed for localized model training on individual vessels. This approach preserved data privacy by avoiding centralization of sensitive information. Each vessel could train its model independently, enhancing security in maritime transportation by minimizing data exposure risk. Out of various available models, the project opted for an ensemble model for intrusion detection due to its exceptional accuracy and F-score. Ensemble models amalgamate predictions from multiple individual models, harnessing their collective intelligence to produce a more accurate and robust final prediction. This choice significantly enhanced the effectiveness of the maritime detection system. The project integrated the system with Flask, a web framework, to ensure a user-friendly deployment. Flask provided an accessible and practical interface, enabling users to interact with the system seamlessly. This integration improved the deployment process and made the system more user-friendly, ultimately contributing to enhancing online security.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.